I'll give you an overview of what this chapter 18 contains. We have spoken about probability distributions. If you missed this probability distribution and this creating the histograms in Excel, then wait till the end. I will also share with you where you can access all those videos. Only those who stay till the end will get access to that. Okay. And we will also talk about normal probabilities and normality test. Okay. Now, I'm going to talk about what is normal distribution. All of you type ND in the chat box for normal distribution. Okay. Now, on a scale of 1 to 10, please give me a 9 or 10 if you know well about normal distribution, or give you a lower number if your knowledge of normal distribution is less. Okay. So most of you know the normal distribution. Some of you have given 0. You don't know what is normal distribution. Fine. This is for me to quickly understand to what extent I should get in the depth of normal distribution. Okay. Right. So this is going to be a little dry. Okay. And I request you to stay till the end. And if you really wanted to become an expert, I'm going to go into the depth of this. Okay. So that you will find here what nobody else teaches. Okay. So normal distribution, the curve looks like this. Okay. And you can see some percentages here, 68%, 95 point something, and 99 point something. So normal distribution, first, this is the most widely used distribution. Okay. This is the most widely used distribution. And there are some characteristics of normal distribution. Only random error is present. There are no special causes. Okay. All of you type NSC in the chat box. No special causes. Only normal or common causes. Okay. And I say this short form and ask you to type because I will keep you engaged. And when you see others typing also, it goes deep in your mind. I hope you are liking this sort of a conversation and engagement, right? So give it a thumbs up in the chat box if you like this. So there are no special causes. There are only common causes. Process is free of assignable cost. The assignable cost is also called as a special cost. Okay. There is no drift or shift. It is having a nice up and down movement. Okay. There is no huge variations. There is only normal variation. There is no huge shift or drift in the table. Okay. Now let's go a little deeper. I want to go a little deeper. Okay. And again, I have shown here mu. What does mu means? I want you to put in the chat box. For those who have attended my session earlier, what does this Greek letter mu means? Come on, quickly, put it in the chat box. Have I opened the chat box? Yes. Yeah, it is called as population mean. Okay. Mu is called as a population mean, and X bar is a sample mean. Okay. This is population mean. Thank you very much for sharing that. Okay. So the mean plus sigma. What is sigma? This is for the benefit of others. Quickly, come on. What is sigma? Sigma is standard deviation. So now, if you see here, the way that is plotted here is the mean plus 1 sigma, the mean minus 1 sigma. The mean plus 2 sigma, the mean minus 2 sigma. The mean plus 3 sigma, the mean minus 3 sigma. Okay. Now, you see a green line here, you see a blue here, you see a pink here. In probability theory and statistics, normal distribution is also called a Gaussian distribution. You can write it in your notes because this is going to be a quiz question. Normal distribution is also known as, I'll give you options, and one of that would be Gaussian distribution. Okay. And this is very, very common. It has got a bell-shaped curve, and there is something called as a probability density function. Don't worry about that. It is called area under this curve. Okay. All of you type area under curve. Okay. AUC in the chat box. There is a bell-shaped curve here. The area under this curve. Okay. The area under this curve for a normal bell-shaped curve is equal to 1. Okay. If you add all the things, then 100% will be inside this curve. 100% of the data will be, so area under this curve will be 1. So area under this curve. Now, density function is nothing but when you go from left to right, okay, What is the percentage of area under the curve? Okay, if this is clear, type super clear SC in the chat box. Okay, you need not know that, but I'm just telling you just for the sake of academic interest. Because if you take the entire area is 100%, so when you actually go from left to right, the area increases. When you cover the entire normal distribution graph, it becomes 100. So that is called density function. Okay, you need not remember this, but just for your academic interest, I have told you. Okay, and there is a formula for this. This formula also you can take a screenshot and keep. The area under this curve, which is called probability density function, which is a function of x, which is the data point, and mean and standard deviation. These are two parameters. Okay, two parameters, and there is a formula here, 1 divided by this thing. Do not worry about the formula. Do not remember the formula. This curve will be automatically generated in Excel, and it will be automatically generated in other softwares also. Okay, this is just for your knowledge. Don't get scared. Okay, all of you type not scared DNS in the chat box if you're not scared. Okay, I want all of you to remove all this because I was scared when I learned statistics in the beginning. Okay, thank you very much. Simple engineering mathematics. Now I wanted to share with you. Now I wanted to remember this something. The center is the mean, median, mode. In a normal distribution, it's a smooth curve, symmetrical. It's a smooth curve, symmetrical. Symmetrical means with respect to center, it's like a mirror image. Left and right is of same area. Okay, and also the same pattern. I wanted you to remember this. In a normal distribution, the mean is equal to median is equal to mode. All of you tap M is equal to M is equal to yeah. Okay, if it is a perfect normal distribution, the mean, median, mode, all the things are same. Okay, M is equal to M is equal to M. And if you see here, it's a mirror image here. These are called symmetry. Okay, and it is unimodal. Unimodal means there is only one mode here. It's not like a camel hump. Some camels have two humps, right? There's only like bull. Okay, only one hump is there, right? And the end, the tail is called as asymptotic. Okay, these are all some words that you have to remember. Awesome. Now today I'm going to practically open the Excel sheet and do something. Okay, but I wanted to explain to you some basics before I go into Excel. Now, if you see here, I have already said the average is in the middle, and there is one standard deviation plus one standard deviation minus one standard deviation, two standard deviation, three standard deviation, all that. Now, all of you, I want you to type below. Okay, I'll open up the chat box. Type in any normal distribution, any data. If you calculate the standard deviation and if you plot plus one standard average plus one standard deviation, average minus one standard deviation, if the data is normal, 68.26% will be within plus or minus one standard deviation. All of you type 68.26 in the chat box. And 95.46% will be between plus or minus two standard deviations. And 99.73 will be plus or minus three standard. It can be for any data. If the data has a normality, if data is normal, you calculate the sigma, you calculate the average, and you put average plus or minus one sigma, approximately 68% will be under that. Data point will be under that. Approximately 95.46 will be between plus or minus 2 sigma and 99.73. And if you have understood this, whatever I've said, please give me a 9 or 10 if you have understood this. This is very important thing to remember. You can take a screenshot of this. All right. Now, less than 1% of the data will fall under the curve outside these three standard deviations. Okay. So if you can see my screen, okay, just type can see in the chat box. Okay. Some person says he cannot see the screen. Dr. Chuck is saying he cannot see. I can see. Type I see yes in the chat box if you can see the screen. Now, I'll go a little deeper into this properties of normal distribution, which you'll have to remember. Okay. I already said mean is equal to median is equal to mode. The area under the curve should be 1. These are two of the quiz questions. Okay. And it will be exact half symmetric mirror image and all that. Okay. The normal distribution should be defined by mean and standard deviation. All of you type M, SD, mean and standard deviation. It is unimodal. We have already seen this. And the curve approaches x-axis and never touches because asymptotical. Okay, it will go till infinity. Okay, I'll go a little deeper into this. If you see, notice the difference between plus or minus 1 standard deviation and plus or minus 1 to 6 standard deviation. Now is the world of Six Sigma coming in. I've already asked you to type 68.27%, 95.45, 99.73. What about 6 standard deviations? 99.9937 will be plus or minus 4 standard deviation. 99.999943 and 99.999998% will fall within plus or minus, which means only 3.4 defects per million would be there. All of you type 3.4 in the chat box. That is why, as you reduce the variations, okay, then all the data points will come closer, and hence you can have good quality products. Only 3.4 per million will be defective. Okay, if you have understood, that is why it is called Six Sigma. If you, those of you who have understood, I don't expect everybody to understand, but those of you who understood, please give me a 9 or 10 if you have understood this very well. Okay, good. There are many people who have understood this. Now, I'm going to scare you with something called as chi-square. Okay, all of you type CHISQU. Okay, or only CHI in the chat box. That is enough. Chi-square. Okay, chi-square. Okay. Now, I'm going to quickly go presentation and actually, okay, how to calculate standard deviation. That also we have given the formula in the earlier video. You can also use the Excel. I'm going to do that in Excel one more time. Okay. Now, if you see this, this is the normal histograms with 16 bins. Okay. We have done this histogram last. How many of you were there during last session? Type LS in the chat box if you're there in the last session. We will use the same histogram to calculate the normal distribution and the chi-square value and check whether it is normal or not. This is the histogram that we had generated. Okay, many of you attended. Those of you who have not attended, don't worry. I will share with you in the presentation here for a few minutes and quickly go to the Excel and demonstrate that. Okay, I'll quickly do that now. So this is a histogram that we generated from Excel last time. Okay, I will do that histogram quickly one more time. Okay, and now what I'm going to do is just please follow me carefully from here. The histogram, whatever that I've shown you, is an example of a chart that does not fall neatly into histogram of the bell-shaped curve. Okay, so there seems to be a skewed data, but then we need to see how close it is to normal distribution by doing this chi-square test. Okay, and you will usually begin exploring the probability data. Now I will take this data and put it in the Excel sheet and I will do some calculations. Okay, first what I'll do is I will generate this histogram. Should I do it quickly one more time in probably 2-3 minutes? Is that okay with you? Type yes in the chat box if you want me to do that. If I see most yes, then I will choose that. Okay, I'll just spend probably just a few seconds to generate this histogram. What I'll do is I will start a new Excel sheet, file new, and I will share the Excel sheet. Okay, just quickly wanted to see if you can see my Excel sheet. Type I can see in the chat box. I see yes in the chat box just to make sure that you can see the Excel sheet. Okay, fine. Now I'll do it in 1 or 2 steps. Don't worry. I'll not take much time. I'll do it in quickly in 1 or 2 steps. Okay. What I'll do here is I'll first copy the data. Okay. So we have, let's see, 50 data points. The first step in generating this Excel sheet is 50 data points. So these are the 50 data points. If you can see this 50 data points here, type yes in the chat box. This is the step number 1. Don't worry, I'll go through really quickly. Okay, good. The second step is go to the data tab and there'll be a data analysis tool pack. you have to choose histogram. This is already taught here. When you click the histogram and say OK, you'll have to select input range, bin range, put it in new sheet and chart output. So let me put the input range. So input range is this, okay? Input range is this. Let me choose everything here. Okay, I'll have to choose the bin also. Bin means the class interval, okay? Those of you who have attended my earlier session, you know bin means class interval. See, for histogram, we should know how many data points are there between class intervals, right? So I would say 10, 15. And in this data point, we have data up to some, I think 75 or something. So I'll choose bins, okay? How many bins are here? Okay, there are some 14 bins here. Okay, fine. So let me go to data analysis, histogram, okay. So I choose the input range first, which is this to this. Oh, I'm sorry, wait. I can select here input range and let me select the bin range here. I will delete this and I will say output options is new worksheet and the chart output. And I will say okay in the chat box. Okay, so I will increase this histogram. If you can see that between 10 to 15, nothing is there. Okay, 15 to 20, one is there. 20 to 25, one is there. And you can see 50 to 55, 10 data points are there. And 70 to 75, one data point is there. Okay, if you can see the histogram, type yes in the chat box. If you can see this. Now, just to get a flavor of a nice histogram, you can use quick layouts and do the histogram. For example, I can go to current design and change the quick layout and do something like this. Okay, so this is a nice histogram that you have got. But we are not sure. This is the same histogram that we have seen in the presentation. Okay. Now, the next step, now that I've done the histogram, actually, this is the data, okay? I will rename the sheet as data, and I will rename this sheet as, okay, bin histogram, okay, bin or histogram. Now, so far, if it is clear on a scale of 1 to 10, please give me a 9 or 10. I've quickly done the histogram. I will not spend much of your time, okay? Super clear? Okay, fine. Now, people were asking me how to calculate standard deviation, okay? If you all can see the screen type, I see yes in the chat box. Okay, sure. Because some people typed, I cannot see. So I just wanted to make sure. I'm sorry that I'll have to ask you again and again because sometimes, because of the Zoom settings, or they are watching from the mobile that they are not able to. You ask for, you wanted to know what is the, let's say, mean, standard deviation, etc., etc. I'll tell you, go to data, and there is something called as descriptive statistics. Okay, descriptive statistics. All of you type DS in the chat box. Descriptive statistics. If you want to calculate mean, median, mode, and everything, don't worry. You can immediately do the descriptive statistics inside Excel. Okay. Good. You can immediately do descriptive statistics. If I say okay, first it will ask for input. Okay, it will ask for input. So I choose this column where the input is there, and I choose everything and grouped by columns. Okay, because it's a column, it is grouped by column. I want to take it to the new sheet, and I wanted the summary statistics. Okay. So this, I will give you the Excel sheet of these steps. Okay. I'll share with you the screenshots. Okay. If this is clear, type SC, super clear in the chat box. It's very important for you to understand this. Now what I'll do is, now that you've chosen these input range, it is grouped by columns. You've chosen this column. You want a new sheet. You say, okay, now you have got the descriptive statistics. Okay. If you've got it, just type got it in the chat box. I will just, for the sake of, I'll do some sort of, let's say, cleanup with this data. Okay. So that everything is two decimal places. So far, if you found it interesting, useful, valuable, fantastic, awesome, just put it in the chat box. Okay. Now what I'll do is, we want mean, standard error. Don't worry about it. I will gray it. Median mode, mean, median mode is there. So standard deviation is there. Don't worry about sample variance. Don't worry about skewness and kurtosis. You need the range. You need maximum, minimum. Some also you need not worry. So whatever that I've highlighted here, okay, whatever I've highlighted here are the main statistics. And mainly you're going to look at Even this median and mode is not so important or so relevant now. Okay. So all I need is mean standard deviation. Okay. And maximum minimum range is also not so important now, but I still leave it at little darker. Okay. And the count is 15. Great. Thank you very much. Now it is getting more interesting. How do you say it is normal or not normal? Okay. Now what I have to do here is I am going to do a certain things here. Please be with me carefully. If you miss it, you will miss the bus. The first thing that I will do is the bin. Okay, bin is a class interval, and we had this bin here. These are the class intervals I had. And I will tell you the logic of what is. I will stop sharing the screen. I will come on the screen and I'll share with you the logic of normal distribution. In a perfect normal distribution, okay, we said it will be symmetrical. In this class intervals, in each of these class intervals, there must be data points. For example, if there is one class interval to the right, if there is one class interval to the left, each of them should have similar data points. Only then it will be symmetrical curve, and only then it will form a normal distribution. If this explanation is clear, type super clear in the chat box. Okay, I will even share one of the slides what I've shown now. Okay, so that you're clear here. I will share with you this slide where if you see here, if I take two bars here, the bar on the left side, the bar on the right side should have the same number of data points. That's what I meant by that. Okay. Okay. Now, in actual, if you see the distribution, I see this data point. I shown this normal. This does not have bars equally on the left and right. Okay. But then, can you conclude it is not a normal distribution, or how do you conclude? So what we do something is, as per normal distribution, how much should be the data points in this bar and how much actually it is. It is called expected and observed. All of you type E for expected and O for observed in the chat box. E for expected and O for observed in the chat box. The height of the bar, I'm expecting to be so and so with so many data points, but the actual observed is so and so. And so the difference between the deviation from the expected and the observed will indicate to us how normal the data is. How many of you are clear with this explanation? Type super clear in the chat box if you're clear with this expectation. So to find out the normal distribution, the chi-squared, it is just saying, was for a particular normal distribution, the data must be symmetrical. The number of bars on the left side, the number of the bars, the height of the bar on the left side, the height of the bar on the right side, all of them should be of a particular length. But actually we see a different height. The difference we will translate that into a number, okay? And that is what is called as a chi-square test. Now, what I'm going to do is, I'm not going to, is it okay that if I take 5 more minutes and do it? Do you want step by step or do you want to show me the Excel sheet completely? Just type it in the chat box. If you want me to share step by step, I will share that. Or if you want me to show the entire thing, because it will take another extra 5-10 minutes, is if it is okay with you. I'm okay. But if you want step by step, okay, most of you want steps, okay? Okay, don't worry. But the problem is you should not drop out, okay, by thinking it is boring, okay? Because these steps nobody will explain to you. Okay, now coming back here, I am putting the bins here. Now what I'll do is, I'm going to share something called as cumulative distribution function to left, which means from the left of the normal distribution curve, I wanted to share with you some function. Okay, let me share with you that function first. That's equal to norm dist. Okay, all of you type norm dist in the chat box. Okay, let me see if the chat box is open. Okay, norm dist in the chat box. This is something that you should remember. If you see the norm dist function, you have to give the value of the x first. Okay, and then you should say the mean. X is actually the bin, and then the mean, standard deviation, and cumulative. Cumulative should be true value. Okay, so all I want is norm distribution is x, comma, and the mean is, okay, if you see, let me show the screen. The mean is this. Okay, the standard deviation is here. This is true. Okay, whatever that I've typed here, I will share with you in the presentation also. Don't worry. You just follow what I'm saying. Okay, so I have this number. Now that this, for each of this bin, I want to show you. So what I'll do here is the function f4 for fixing this mean and standard deviation. There are two parameters, function f4. Okay, and then with this, I will share this Excel sheet. Don't worry. So what it means that is, if you see here, suppose if you convert this into percentage, let me just quickly put you into the percentage. If you see, almost 99.99% will come here. Okay, so it is the just 1% will be left. The entire area under the curve is taken step by step. If this is clear, give me a 9 or 10 if it is clear. If you're not clear, don't worry about that. Okay, so it only shows that from the left, if you come, there are some bars here, and if you add all the bars to the end right, it will cover 100%. So this is cumulative distribution function. Cumulative distribution function, CDF. All of you type CDF in the chat box. Now, this is bin only because in the bin 10, it forms this, and both of them it is here, and the entire thing it is 98%. Now, if you want to calculate the bin only, in this bin it is only this, but in this bin it is this minus this. So much percentage in this bin. Okay, I'll copy here. So we are just seeing, see, if you see the total of all this, it will be almost 99%. Can you see that the total of all this is? Yes, type I can see in the chat box. So each of the bin add to. So each of the bin percentage of data points in each of the bin is here. Okay. Okay. Now, since so much percentage is there, since we know the count is, okay, fine. Please focus. Okay. Now this is called, now the expected count, the expected in each bin is, this star, the count of this. Okay, we have so many data points. I'll put a dollar to fix this function f4 I'll use. So I expect so much. Okay, just for the sake of this thing, I expect so many data points in each of these bars, in each of these class intervals. But what I've observed in the bin is only this. I will copy this observed here. Now, this is what you need to understand. See, expected is 0.02, but observed is 0. Expected is 0.06, observed is this. If it is a perfect normal distribution, this is what would be expected. But the observed is this. Against 10, against 8, it is 10. Against 8.5, it is 11. So for the perfect normal distribution, the expected is this, but observed is this. So for chi-squared, what we do is, now only thing is you need to understand, we need to do what is expected minus observed squared divided by expected. That is what is, the sum of this is called chi-square statistics. Okay, what is chi-squared statistics? We need to find out expected minus observed square. Okay, I'll put in the bracket E minus O square. Okay, divided by expected, I'll have to do. So what I'll do is, this is expected and minus, okay, I'll put a bracket, sorry, expected minus observed, and where is square? Okay, and I will expected, and this is chi-square statistics for calculating this one, E minus O square divided by expected. Okay, this particular value, I will just copy this here so that, so this divided by expected. Now, as per nobody will teach this. Okay, so the chi-square statistics is actually the sum of all this. Okay, what do you see as the sum of all this? Type it in the chat box. What do you see as the sum of all this? Now I'll tell you how to find out whether it is normal distribution or all that. What do you see as the sum of all that? This is called chi-square statistics. Okay. And nobody teaches you, okay? Nobody teaches you. This is a golden opportunity. How many of you feel this is a golden opportunity for you to learn this? Type GO in the chat box. Okay, fine. Thank you very much. Now, quickly. See, we in hypothesis testing for normal distribution, there is a null hypothesis, there is an alternate hypothesis. Null hypothesis called as H0. Don't worry about all this, just follow me, okay? This is called as alternate, is called as H1 or HA, okay? And data is normal, okay? And there is something called as p-value, which should be less than 0.05. This is called probabilistic value, okay? If p-value is high, then null is the guide. If p-value is low, null must go. Okay, so these are the things that I want you to just remember, because it is called as, you make a claim that this is a normal distribution. So the claim is called as a null hypothesis. This is called as a claim, okay? You make a claim, you don't know whether it is a normal distribution. You don't know whether it is a normal distribution. What is a way to find out that it is a normal distribution? The only way to find a normal distribution, if you do research, I'm a doctorate in lean system. If you do your research, there is something called as a null hypothesis. There is something called as an alternate hypothesis. In the null hypothesis, we are claiming that it's a normal distribution. The alternate hypothesis, that it's not a normal distribution. Now, how do we know that? Please calculate p-value. All of you type p-value in the chat box. You can just type p in the chat box or pv in the chat box. You have to calculate the p-value. But how do I calculate the p-value? P-value can be calculated first by using chi-square statistics and a formula. Okay. Thank you very much for your active participation. And there are not many dropouts. I'm very glad. I'll just wind up in 5 minutes. Okay. Now that you need two things. One is chi-square statistics and degrees of freedom. All of you type DOF in the chat box. Degrees of freedom in the chat box. I'm going to type here degrees of freedom. It depends upon two factors. Number one factor is number of bins, 1 bins. And the second one is, okay, the number of parameters. Here we have two parameters. Here we have 14 bins. Okay. What is bins here? The bin is nothing but this one. If you see here, there are 14 bins. Okay. So 14 bins, and parameters is these two parameters, which is mean and standard deviation. There are two parameters. Okay, two parameters. So the formula for degrees of parameter is, okay, let me quickly share with you the formula for. It is actually number of bins. I'll better copy and paste so that I don't waste time in typing. So the number of degrees of freedom is, where is this? Okay, fine. Please allow me to copy. Why am I not able to copy? Just a moment. Let me try again. Degrees of freedom. I've copied from presentation so that I don't waste time. Number of bins minus 1 into this thing. Number of bins minus 1 is 13. Okay. Minus degrees of freedom 2. So total is 11. Okay. So degrees of freedom is 11. So degrees of freedom is nothing but number of bins minus 1, which is 13, minus the number of parameters, which is mean and standard deviation, which is 11. So degrees of freedom is 11. Okay. If you have understood, type US in the chat box. If you have not understood, don't worry at all. Okay. Don't worry at all. Now, the p-value is calculated by a function called, okay, good. If you've understood, it is good. The p-value is calculated by a function called, let me just insert here some rows. Okay. Just a moment. Okay. This is called chi-squared function. I want all of you to type is equal to CHIDST. Okay, chi-squared distribution. Can you all type CHIDIST? CHIDIST. Chi-squared distribution. Okay. Chi-squared distribution. Correct. Okay. So chi-squared distribution. Just a moment. Okay, this is to find out whether it is normal or not. Okay. Okay, chi-squared distribution of the chi-squared statistics and degrees of freedom. Okay, chi-squared statistics, comma, and the degrees of freedom here. Sorry, chi-squared statistics, comma, and the degrees of freedom, and enter this. So you see a value of 0.11. What value do you see? Type it in the chat box. What value do you see? This is called p-value. 0.116. So the p-value should be less than 0.05. If p-value is less than 0.05, if p-value is low, null must go. If p-value is high. Now you type me whether it is low or high than 0.05. Tell me whether it is low or higher than 0.05. High. So if p-value is high, the null is the guy, null is data is normal. All of you say data is normal in the chat box. Data is normal in the chat box. And if this was interesting, useful, valuable, fantastic, awesome, put it in the chat box because I've spent a lot of energy in discussing this. Okay. And I really wanted to, get your views on how you felt. So, how many of you are ready for 5 question and answers? Quick 5 question and answers, type ready in the chat box. Only 5, which will take a few seconds. Ready? Okay, fine. Okay, what is the key characteristic of a perfectly normal distribution? Let's quickly see the correct answer. What is the correct answer? C, which is mean, is equal to median, is equal to more. All right, C is the correct answer. Yeah. A normal distribution is symmetrical, so mean is equal to median is equal to more. The second question we had is, okay, what percentage of data fall within plus or minus 1 standard deviation? Anybody remembers? 68.27 is the right answer. So 68.27 is a right answer. Okay, third question. Okay, 2 more questions. So which is the test that is used in Excel to determine if the data is normally distributed? Chi-square test is the right answer. This is what we have seen now. We have done all over. Okay, fantastic. 2 more questions. What is the significance of p-value greater than 0.05 in chi-square test of normality? What is p squared greater than? What does it mean? Data is normal. Null is the guy. Fantastic. Except the null hypothesis, data is normal. Fantastic. Fantastic. Last question. In the normal distribution, how much data fall between plus or minus 3 standard deviation? 99.75. All right. Thank you very much.